Okay, so now that we have a definition for domain and range, let's go back to our relation function worksheet, if you would. And we already know which ones are functions and which ones aren't. Let's go back and talk about what inputs are in the domain and what outputs are in the range. So again, our definition, a domain is a set of inputs that create an output. So they actually make the rule, whatever the rule is, work. Range is the set of outputs that are created by the rule. So if we look at the first schematic here, what we see are A, B, C, and D. Now there are a lot of other alphabets, right? There's E, F, G, H, all the way down to Z and all their lower cases. But as far as this relation is concerned, as far as this function is concerned, there's only these 4 letters that are actually producing some sort of an output. So my domain, it's discrete, would just be the letters A, B, C, and D. Of course, there's nothing in between those values, so there's only 4 values. There's only 4 things in the set, A, B, C, and D. What's the outputs? Well, we can see that there's only 3 distinct outputs, right? 1 is being created, 2 is being created, and 3 is being created. So the range only consists of those 3 values. And again, we're dealing with discrete sets at the moment. D, for domain for this guy, well, again, there's a lot of other Greek letters that exist, but the only 4 that seem to be doing anything are alpha and beta and omega and delta. So there would be my domain listed as a discrete set. The range, well, the 4 symbols that come out using my set notation is a $, a %, a number sign, and a question mark. So again, we list a discrete set with a nice little curly brackets. What are the inputs for this schematic? Well, again, there's thousands. There's an infinite number of numbers out in the number world. But as far as the schematic is concerned, it only seems like 1, 2, and 3 are producing outputs. So my set would be 1, 2, 3 with the nice curly brackets. What about my range? Well, only 3 values seem to come out in this schematic. So 4, 5, 6 would be the range. Hope you guys are getting the hang of it. Let me do a couple more. So for this table of values, again, there's thousands, there's millions, there's infinite number of x values. But as far as the schematic is concerned, the only values that create an output is -2, -1, 0, 1, and 2. And we list it off with the curly brackets. So there's only 5 values, nothing in between -2 and 2, just the 5 distinct values, -2, -1, 0, 1, and 2. What's in the range? Well, it only looks like there's 2 values that come out as far as this is concerned. 4 and 5 are the only 2 values that seem to come out of that. So again, domain, values that I can put in that actually show or create an output. So this domain had 5 values in it. This range had 2. All right, so let me back away from schematics. Let's go ahead and look at some graphs. So for this graph, again, we're looking for x values that create y values. So there are a lot of x values, right? There's tons of them. There's an infinite number, but it only looks like -4 is producing an output, -2 produces an output, 0 produces 1, 2, and 4. I only see data points at those 5 input values. So the domain is strictly restricted to those 5 values. What about the range? Well, again, since this is restricted, the range is going to be restricted. So it looks like at its lowest we have -1 in the range, 0 is in the range, 1 is in the range, and that looks like it's 3. So the range for here are all the outputs that were created by these 5 inputs, -1, 0, 1, and 3. And again, we're talking about a discrete set using our curly set brackets. The next one, again, looking at the x values, what's in the domain? Well, listing wise, it looks like we're all the way down at -4. That looks like -2, -1, 0, 1, 2, 3, and 4. 1, 2, 3, and 4. So our domain consists of those, looks like 8 values. So every x value in this domain is creating a y value. And I see that creation because I see a data point associated with each one. This value, right, has no, the value of 1, 2, 3, 4, 5 has no associated point with it. So it's not in the domain. I don't know where 5 goes. I can predict it, but I don't know for sure. Not in the domain. The range, well, what comes out of this, it looks like we have at the lowest, it looks like a value of -5, and then it looks like we have -3, -2, -1, I'm running out of room, sorry about that, comma, looks like 0, and 1, and 2, and is that a 4? Hope I'm reading my own graph right. So this has 5 different values, or looks like 7 different values that come out. All right, so again, the idea of what values can I put in that actually show something happening. That's what puts me in the domain, a set of inputs that create an output. What's in the range? The set of the outputs that are created. Right now we've had what are called discrete sets. We're not talking about intervals, we're just talking about distinct values. But it changes up in this one. And again, we'll talk more about this in 7.2, but let's get a feel for it right now. This graph, this arrow indicates that it goes on forever. So eventually, every x value that we have, right, from positive infinity down to negative infinity, they're eventually going to have a y value associated with it, because that's what those arrows are indicating, that this is going to go on forever and ever. So we'll eventually be out as far as we can go. So the domain in this case would be negative infinity to infinity. This is what we call interval notation, and I am truly talking about every single number you can dream up of between negative infinity to infinity. What about the range? Well, the range is limited, right? Starting at about -3, right? It looks like every y value going down to negative infinity, right, is in the range. So negative infinity up to 3 with a bracket there, that would be what the range is. So you can put any number you want into this relation or this function, but what's going to come out is anything essentially below 3. So 5's not in the range, and 6 isn't in the range, or none of these values up here, because the graph, right, the solution points don't seem to be associated with it. So there's no x value that would create these y values way up here. These x values only create things below 3. Domain and range. Let's keep on learning.